Hey, today I want to discuss you how we're using micro-frontend approach in Namecheap.com. So let's start from question, who am I? So I'm playing a role of solution architect at Namecheap.com. I worked in lots of different companies. Yeah, I was a founder of Kharkiv JS conference, one of the biggest JavaScript conference in Ukraine. Unfortunately, I cannot run it anymore because of situation in Ukraine. So right now I'm working as a founder of a charity foundation fund called Stellar Ukraine. You can donate something and help to Ukraine if you wish. So today, it's my social media. You can follow me on GitHub or Twitter. And today I will tell you a story about our in-house solution called Isomorphic Layout Composer. It's a tool that help us to manage our microservices on front end. So I want to present our technology because I followed lots of different conferences, lots of different articles, and in my opinion, when people start talking about micro-frontends, their main accent on code sharing. But there are lots of questions around which need to be solved, like deployment pipelines, like support of SSR, like error handling, and so and so. So I want you to tell a story about how and why we decided to use microservices in our company. So Namecheap.com is the second biggest world domain registrator, and we have lots of different products like site builders, hosting, VPN, and so and so and so. So it's a large ecosystem, and we manage everything of it in one single website. So we have lots of team, we have lots of front end, and we have lots of challenges. This story starts with a reference to the past. So somewhere in 2014, almost all companies start talking about what is the reason to use microservices. So they thought that microservices increases your resilience, improves scalability, allow to use right tools for right task. It allows them to use different technology, go for process something to make some heavy computation, not just to serve static, and so and so. Microservices allowed to make delivery faster and more flexible. As well, it provide ability to make debugging easier, and as well it allowed to maintain your code without huge knowledge of all your monolith principles, APIs, and ideas beside. From one side, it can improve your return of investment because reducing of technical stuff. You can run your services on cheaper instances, for example, and so. And of course, it allows mitigate convoy low risk. So that's what we thought in 2014. Somewhere between 17 and 18, communities start talking that microservices is not a silver bullet. Microservices is not for every project, is not for every team, and I would agree with it. And as I remember in 2018 on Fowler's blog, there was one article about we are talking tomorrow about microservices on backend. What about using this approach on front end? So our history is really similar to what was in mainstream community conversation. So in 2015, we started migrating our monolith service to microservices. In a year, monolith becomes smaller, amount of microservices grows, nobody cares about front end. Usually in big company, the main accent is on backend and frontend just working. But when your frontend is rich, your frontend can become bigger problems than even your all nodes that run your backend. In 2 years, monolith becomes smaller and smaller. Microservices are everywhere, but nobody cares about frontend. And only after 3 years, we decided to stop and to think about what to do with our frontend, because right now it's our bottleneck. The frontend do not allow us to make releases every hour, and it not allow us to deliver enough performant page to our customers. So frontend is bottleneck, and it's even harder, it's even more complex than backend. And we have some well-known pattern how to use microservices in backend, but what about frontend? We have almost nothing on the market. So usually after extraction, infrastructure or architecture of your project looks something like that. You have clear defined bound and context for your microservices, but your frontend is a messy service, and generally it can be anything you can imagine. It could be some not supported CMS, some still supported CMS, but someone in your company made monkey patch and you cannot update it. It can be lots of different services run by your load balancer or your gateway, and each time you need to add new page and you need to update your gateway, so you need to involve in the process lots of team. So as for me, it's not correct. I just want to allow to developer deploy their service and ensure that the page is available for customers right after deployment without any manual involvement of any other team. That's a goal, and that's something we need to um, implement in our infrastructure if we want to become really technology company. So what we really had in 2018, we had a CMS that served ton of page. Nobody knows how the CMS works in details. Nobody wanted to work with CMS and with this front-end page. It was really hard to hire any front-end developers because in 2019, almost all front-end developers wanted to want with hype technology like React, Vue.js, Angular, I don't know, even Svelte and others. So nobody wants to work with your legacy CMS. It's a problem. Some of our front-end services were served by Node.js nodes, and our gateway manage them. So it's a bit better approach, but to release new pages or new set of pages, we need a communication between someone from someone from DevOps team, from SRE team, with our developers, and that's not what we wanted. We just want to allow to deploy everything and avoid over communication in company. Of course, we had no rules of how to build frontends. All teams had the ability to choose their own technology. We didn't have any agreement, so that leads to a situation when different teams created their transport models. They did the similar mistakes, and we just tried to manage it, but system was, to be true, not manageable. Our Lighthouse core on desktop with normal network connectivity was between 14 and 17. That's not very performant, as you can see. Of course, on each page we have dozens of unknown scripts. Some of them were provided by developer team, some of them were provided by business analyst team, and we don't have a person in company who could explain why do we need all these scripts. And removing of them leads to situation when random page failed by random reasons. And of course, we have lots of dependency with a different version. So on pages, we had several Bootstrap CSS from framework. We could have same models or same calendar instance with a different version. We had a conflict, and that didn't make our delivery process faster, and our business representatives wasn't very happy with it. So we decided to deal somehow with it, and our next step was decrease amount of pages served by our CMS and try to build microservices that was a bit different from backend one. We call them backend for frontend. We try to follow backend for frontend pattern. So that services were responsible for delivering static, and they could have some internal API that serve some kind of data to the services. Backend for frontend had ability to communicate with backend services as well. And we have a gateway that manage all the services together to allow to gather them in and deliver behind the one domain. So we reached ability to make independent deploys. We had front-end agnostic approach. Developers got ability to use modern technology. Developer experience start um, stabilize. I would say stabilize here, and we got ability to make change faster. But what about structural consistency? Here I'm talking about the pages that have similar parts on it. The good example of it just similar news or about us or contact page that consists of header, footer, and main part. So what about someone change something in header? What's it meant for us? It meant that all team who contains this part of UI need to make a redeployment of their service. So it took us a week to make this part of UI consistent. From what I see right now, lots of company has a similar problem. We had UI consistency problem because we didn't manage version of design system components on the pages. So on different pages, we could have different drop downs. So that's not a big deal, but I think our end users suffers about it because they want to use really smoothie and modern UI. Um, we had a problem with cross-dependent releases. So if someone's page uh, needs some changes, team need to analyze if this change affect other pages. If they didn't do it, we got inconsistency. If they goes by process, they need to contact lots of team who need to make these updates as well. We didn't have clear system of sharing UI functionality, and of course, this approach don't allow us to reuse different part of UI on different pages. So this solution was a middle ground, but it did not resolve our goals and our requirements. So we decided to stop a bit, and we start talking about why we can't use the same approach we have on backend. Why we can't write front-end microservices. So our goals was to split the page on different fragments. One page can consist of several fragments. We talked about kind of news page that contain header, body, and footer. So you can imagine that fragment is separately header, footer, and body. The idea is each fragment is independent application. So team has not developed pages. Team have to develop fragments. And we need some kind of engine that would be like a glue for these fragments to deliver the final page to the customer. Application has to support client-side navigation. So All systems have to work like single-page application. In the same time, we need server-side rendering because we have both storefront and back office. But I would say that the majority of our page are storefront, lots of pages with information, lots of indexed pages, and we don't want to lose our position in search engines. So SSR should be supported out of the box. And of course, our designers wanted to make UI consistent and then don't want to see different UI elements on different pages because it makes life of our customers harder. So we decided to make some requirements. That's just part of them. So we want HTML page has to be delivered by layout streaming system. A unit of streaming system is a fragment. Streaming should be light and fast. Fragment is just a regular front-end application, so developer should know nothing about engine that will work like a glue for this fragment. Development team just need to develop their front-end and don't think about full picture. Of course, they have to do it, but we don't want to make the work overcomplicated about tooling, about approaches, about our architecture. I think that developers need to develop their front-end pages, backend developers need to deliver the APIs, and that's all. We don't want to overcomplicate their life. We want to think about development experience. We want a development team can use different frameworks. They can make an experiments. We don't want to render lock on some popular framework because we know that in several years things gonna be changed and we will need to migrate part of our services to some other technology. We want to have isolated CSS and we want to support global roads. So we don't want to manage all roads on gateway side. We want to manage it on our front-end engine microservices. This fragment should be delivered by the team and delivery should be independent. So I can change any fragment without involvement any other team, and after deployment the change should be propagated to all page where all page which needs this fragment. Fragment should know nothing about others. It's isolated part of the system. So if team needs to communicate between fragments, they can do it, but it's not a part of front-end engine framework, and we can do it in different ways. And of course, we wanted to make code sharing. From organizational goals, we wanted to mitigate convoy risk. We don't want our customer structure, our company structure dictates our microservice, dictates our architecture. We want our architecture allows us to build color-correct company structure. We want to make team as independent as possible because we can see over communication in different teams. We want team need to be concentrated on the business value, on technology excellence, not about communication of how to make this release consistent. So that's infrastructural goals, and all that stuff need to be solved on infrastructure level. Applications, I mean fragments, and all system should be testable and reliable. And as I said before, we want to avoid communication overkill because it was one of our pain. So generally, we wanted to see such kind of, we have a page. Page consists of several applications. Each application can be owned by different teams. Each part of page can be delivered, deployed independently. If something is deployed, page is changed, other teams that does not participate in this process. If one part of page is deployed, we can run test that covers all page and this application in silo. So that's a simplified diagram that show how we wanted to see our architecture. So here, behind the gateway or load balancer, we have to put microservice engine. This microservice engine has to process route based on route. It have to determine what page need to be rendered. Based on it, it gets knowledge about of which fragment this page consists. It glue all fragments together, and these fragments acts like a regular front-end app on your favorite framework like React, Vue, Angular, and communicate with some backend services. Of course, if your project is not start from scratch, you will have some scary part of your front end. That's reality, and of course, we need to take care about it. So, in the final, we decided to have something like that. In browser, we have these fragments. Browsers make a request to your load balancer communicates with your Microsoft Engine communicates with process header requests and communicate to front-end Microsoft Registry Engine knows about your pages, templates, and all other entity I will explain you later. Microservice Engine runs several HTTP streams to get response from a developer's fragment. It forms an HTML page and respond to the customer. That's the idea. So generally, Microservice Engine is responsible to process incoming requests, discover page fragment, communicate to fragment services, and form HTML. So it's just a service that provide you final result of the page this customer can see in the browser. Microservice registry is a RESTful API service that has persistency and know about system entities. And Fragment is just a part that usually team works on. It's just a fragment, it's just a front-end service. So how it works together? Browser initiate request. The gateway proxy passes request to Microsoft Engine. Microsoft Engine, based on headers, analyze routing data and request page information from registry engine. This page information consists information about which fragments are part of this page. Based on this information, Microsoft Engine discover how to communicate to these fragments and initiate parallel requests to the services. These services provide provide static content. So this part of the page. Since all requests are done, Microsoft front-end microservice engine forms the result page, inject some scripts into your head, for example, and inject some JSON configuration objects that will allow us to optimize working on client side. On client side, we are loading microservice engine core script. We are loading injected fragment scripts provided by Fragment itself and parse configuration object. Configuration object allow us to build abstract layer that allow us to manage client-side routing, renders of the page, and all logic required for your application. Since it's done, it matches the router, load ESM models for fragments. Since loaded, they initiate rendering or iteration if you support server-side rendering. On client side and on server side, we had a requirement to build client navigation if it's possible. It's possible in the majority of situation. So to achieve it, we have two-tier routing. One part of the router is on Microsoft Engine service. The second tier is on your application. So developers just build regular application that cares about routing. The routing is a part of the system. The first part of parsing is on frontend engine. So if we receive requests like route/ms1, microservice engine parse the first part of the route, and then it bypass a base URL to your service. Your service, it react on it in a way it wants. So you just can put regular React router or Vue router in your application and work with it as with regular router. Route has association with template. What is template? Template is extended HTML syntaxes that can have some directives. This directive is a kind of association with remote fragment. So here we can see that our page consists of three fragments called navigation bar, body, and footer. All of them are separate independent applications. You can customize your template as you want. So just put your tags here and use your styles. Router, and each route has knowledge about these slots. It's a kind of anchor for your front-end application. When I'm talking about front-end application in this context, I mean service that serve static for your front-end application. So the full picture looks like that. Routers knows about templates and slots. Based on templates, it can analyze which slot belongs to which application and make a discovery of this application. How to integrate your application with front-end engine. On client side, in the very simple scenario, you need to integrate only three callbacks: bootstrap, mount, and unmount. I think you already understand what's the meaning for them, but generally bootstrap is called once right before mount happen. On mount, you just need to get the DOM node, which is created for your fragment, and render your application in this node. On unmount, you need to ensure you clear everything from your DOM elements, DOM event listeners, leaked memory, globals, observables, etc. That's it. On server side, you need to process in special way request and response. In request, frontend engine provide you information about property. It contain base path and request URL. So that allow you to handle routing in your SSR. It has application property as well on client side. So it's a kind of configuration. You can specify what kind of property will receive each your fragment on each route, and you can customize it. Depends on what data you need to pass in your application on each route. And it contains some HTTP headers. Response should contain body with HTML you are provided to customer. So Microsoft Engine will glue it together. It will analyze header link and will put it into head tag. And in addition, you can customize your title by X head title header and your metadata by X head meta header. So that's example of how you can process your response. So function process response just mutate HTTP response by assigning page title to headers, page meta tags to headers, and app assets to links header. So you can think about a part of your backend application to make possible to integrate SSR into front-end engine service. And you just need to send to customer, not to customer, to front-end engine service and HTML generated by your application. It's optional. If you don't want to support SSR, you don't need to do it. How it affects development, you would ask, I think. Our goal is not affect development at all. We want to build separate systems that provide micro-frontend approach in company, but we don't want to change developer experience because in case we are changing it, we need to teach dozens of team to use these tools. We just want team deliver their regular application without changing their context and without spending time on learning new stuff. In reality, it's almost not affected. Overcomplications is only on integration level, but how we can handle it? We can handle it by adapters. In our GitHub repository, we have adapter for React because for now React is our main technology. I think in future we will create adapter for Vue.js and for Angular as well. But I think that the best thing we could do to mitigate this complication issue. So developer still can choose a favorite framework, CSS approach, decide if they need SSR or don't need. They can control the build process, so we do not dictate how to build the project. It's on developer side. And of course, they can continue control the deploy. They can choose the CDN network or another strategy of deployment front-end static. That's up to them. So what we have? We have front-end microservice engines that allow us to build pages by different fragment. Fragment is independent applications. It's a part of your infrastructure that could be a pod in Kubernetes or in some other infrastructure. Fragment can be deployed independently. After deploy, it changes all pages where it exists without participation of page owner or other fragments owners on this page. Application can support client-side and server-side navigation. SSR is out of the box, so looks like we reach all our goals. It's a kind of culmination, but not the end, because we still have lots of problems on front end we have to solve. I would explain not about all of them, but about a part. So how to configure this engine? I talked that we have some registry, so we need to put some data on it. We have admin panel approach, but I'm not sure that you need microservice front-end microservices and configure it via admin panel, because if you need front-end microservices, it means that you want to scale your front-end. If you're scaling your front-end, it's enormous. If you're configuring your enormous large service in admin panel, you are not protected from manual mistakes, and I think your DevOps won't be happy about it. Maybe not DevOps, by team who responds from infrastructure. So instead of admin panel, we are recommended to use configuration as a code. How it can be used? We have a registry. Registry provides REST API service. So you can integrate your build deployment pipeline with ILC registry and configure it as a part of your pipeline. I think it's a great benefit. Let's talk a bit about reliability. I think it's fine when everything was fine, isn't it? Everything is work. What happens if one of your fragment is not available anymore? What happens if all of your fragment is not available anymore? Who need be responsible to handle these cases? That's really frequent question in different companies. So we are providing a way to handle it. So here is a list of reasons why it can happen, but I think you are well prepared and you know that error can happen anywhere. So what's our philosophy about error handling? We want customer not suffer using our services. We uh, want to build such system when uh, if one of front-end microservices is not available or throw an error, the page is not broken and customer can use other part on it. That's important. It's kind of microservice philosophy on backend, and I think it's the same on frontend. And we want our business and development department can define their fault tolerance strategy on their side. We don't want to dictate them. We want to provide a tool to manage it. So to achieve some result, we decided to set some types for our fragment: primary, essential, and regular. So primary fragment can be only one fragment on your page. It's a kind of main valuable part of this page. And in case if SSR responds with error, or if any error on client side, we interpret it as a critical error, and we are showing to customer global 500 error. Essential fragment. The idea of that fragment is to allow to try a second attempt on the client side in case if SSR is not responsible. It could be possible in case when SSR cannot build your page by some reason, but on client side we have already loaded scripts and we can build a part of page on client side. So in that case, we will not have a correct HTML, but customers don't care about it. So he will still see all page, but we will receive some notification in our logger system or error collector, and we'll start reacting on it. And regular types. So if it throws an error on SSR or on client side, we just try to do several attempts to render it. If we have no luck, we just hide this component, we just hide this fragment, and it's not available for the customer, but other part of page is available. So developer manage how your application reacts on error, and it can be kind of part of your configuration system. What about other errors? We are providing a way to handle 404 error. So if road is not available on MS engine level, MS I mean front-end microservice engine, we are throwing global 404 error. Of course, we can handle scenarios when road is not exist on application level or entity is not exist. In that case, we are providing API to Fragment, so Fragment can throw this error on its side, and microservice engine will correctly handle it and show 404 error to customer. We are providing API to handle page transition. So we allow to customize loaders, and we are handling rendering of page on the application. We have entity calls transition hooks that allow you to embed your custom code when page navigation happens. Here you can have stop rendering execution and run some logic like authentication, for example, to analyze if this page available for your customer or some other logic. So based on your logic, you can run redirect, you can continue transition, or you can throw an error like 500 or 404. Front-end engine system supports plugin system. So page transition is a plugin. We have reporting plugin, so you can configure your error system to listen to global errors. We are trying to separate errors from different fragments to allow you to configure correct login on it and separate tenants, let's say, during your team. And also we have localization plugin that allow us to use internationalization on the website. It handles a situation when localization is changing. So we need to handle that each application will load their part of localization through the network. And also it can be used to handle, for example, your multi-currency system. Code sharing is important part of modern front-end microservices. So one of concept we're using called shared libraries. So we talked mostly about Fragment as a part of these pages, but of course we have different dynamic models that could not be part of your server-side rendering. The good example of it kind of warning and information messaging systems that could be similar across all pages. And what we want to achieve, we want to put such library into the registry. We want to create independent delivery of them. And we want that if owner of this library makes some changes, all changes are propagated to all other pages. So each page and each fragment use only latest version of this shared library. So it allows us to build UI in consistent way. So since I change something, let's say color of warning or button on info pages, the changes is propagated over all pages in the system. We have code sharing problem as well. So we have several fragments of the page. We have a situation, usually in our case, we're using React or Vue.js. So we don't want to make React a part of bundle of each fragment of course, as well as Mobix, as well as our localization library, as well as event bus. And we want to ensure all fragments use same version of library. So we are providing an additional directive into our template system. The difference from slots is it cannot render any HTML directly, but it can inject all scripts. So the responsibility of such shared fragments is to deliver reusable and shared code. So it allows us to configure builds of our fragment in special way when they can rely on some dependency is a part of microservices engine. So in local development, they're using as a part of the bundle, but in production, bundle become lighter and you relying on a shared code system. One of the big problem is the local development. So what developer don't want to do almost everything. Developers don't want to run tons of Docker's container. So in our case, we have lots of microservices and microservices on front end, and to mimic a real case scenario, we need to run, I think, at least 9 or even 10 Docker container. Developer don't want to check out tons of different Git repo and so. What developer wants is just to run npm start, and I think that's not very bad. So let's look onto following situation. We have a page and you are developing application number 2. So how it works in production? In simplest case, static are delivered from some CDN and SSR are provided by some remote server. So how to make possible local development? We have cookie management configuration that allow us to switch sources of your application to local static and local server. So you can just run your local SSR and serve somehow your static. And your application, part of the page, will be delivered from your local machine. Everything else will be delivered from production. And since we are following the concept that application are independent, that works for us. So in company development, we use Chrome plugin to make our developer life easier. So they just need to run this Chrome plugin and run command something like npm start dev. It's still not open sourced, but that's idea behind it. Hope we will open source it in nearest future. And performance means for us, because we have lots of traffic, lots of customer, lots of different advertising companies, and to guarantee good performance, we are using our engines as a stateless server, so we can scale them horizontally, depends on loading. We are using built-in hashes described in our documentation, so we are reducing heavy computation and database requests. And we made our client-side logic of core backend agnostic. So it just load configuration object, and all logic is built behind this configuration, so it doesn't have backend requests. So in the end, I would say that microservices, both front-end and back-end, increase complexity on your front-end and back-end. That's true, and you don't always need them. Front-end microservices is not about code splitting. It's also about performance. It's also about delivering. It's also about local development. Lots of problems around. Front-end microservices shouldn't affect the experience of your teams, because usually you need front-end microservices in large companies when you have dozens of teams, and it costs too much to teach all team to use new technology. Front-end microservices as well as backend need to be fault tolerant, and everybody have to think about it. Since you have complicated page that consists of several fragments and several teams owns it, you need robust monitoring system as well, because without it, it would be hard to identify what's problem happens and who is responsible to fix it, because several teams can own one page. And local development is also a challenge. So since you are using some microservice approach on frontend, you need to think how you will debug it and how you will develop it locally. You need to care about your teams. So what isomorphic layout composer, our in-house built solution, allows? So we can deliver different part of pages independently as independent web services. We support isomorphic client-side and server-side navigation. We support SSR rendering. We have handling system. We have fault tolerance system, so teams can decide how to work with it on their side. We are providing suggested solution for local development, so team can affect only their fragment without without running tons of Docker containers and check out and pulling tons of different Git repository. You're working only with one your repository and one your local server, for example, in best case scenario. We are providing ability to monitor the system by using internal plugin system. Transition hooks allows you to embed authorization capability into your system in single place without disturbing all team. We have multi-domain support, so one instance of isomorphic layout composer can deliver pages, templates on different domains. This is our internal case, and we do think that this feature could be also important for other companies. We are providing ability to use configuration as a code on your supply chain level. And we don't want and we don't break regular experience of developers. So here you can see my social media and ask question in Twitter. I didn't talk about all parts of the system I wanted, so I have a plan to continue in Twitter, maybe this evening, to describe different parts and different philosophy behind our solution. Here you can see in two links, it's our GitHub repository and our documentation website. As well, you can find a demo to play with it. You can open admin panel to see how it's organized, and you can go through our pages that built on React View and see how different fragments works on the page. And here you can see some inspiration links. Of course, Fowler's blog article about front-end microservices, single SPA project that is a part of our internal solution, and some other important link related to topic about front-end microservices. So that's all. Thank you so much. Hope you are interested in this topic. And I want to repeat that I don't recommend to use microservices on frontend to everybody. That makes infrastructure more complex. You need to identify if you have some problem with scaling, with team management, with performance or velocity of delivery, and you can be responsible on making this solution. So our solution is used in production. Our solution is tested. It's not perfect, but that's something you can look on. If you have some question, please feel free to contact me social media or in my Telegram or so. I would also always happy to answer a question. Thank you so much.
Thank you, Artem, for your talk. It was really interesting. And we have a couple of questions. What risks are not obvious using micro-frontend? How to solve them?
That's interesting question. So I would recommend to use microservices only in situation when your front end is enormous big and you want to scale it. So that's more about company structure and delivery process than about technologies. I would say that I would prefer to work with a front end that don't use front end microservices because it becomes more complex, and sometimes you don't have enough flexibility to make things in the way you want it. You still have some abstraction layer that don't allow you to do things in a way you regularly did before. So decision of using microservices is really responsible because you are changing infrastructure of front end in your company, and it sometimes it overcomplicate development. But if you go to speed up development, if you go to make page delivery faster, it can work. I'm not sure if I answer this question. We can continue discussion in Discord because it's a bit wide question.
Okay, and the last one, because we have out of track now, where do we need to use CSR which projects are good for server-side rendering? Because you have mentioned
Mhm.
maybe just for some.
I think that nowadays we need to use SSR for page that need to be indexed by search engines. So I think that's a major case. If you need to deliver landing pages or page with content and you cares about position of your website in Google, Bing, and other search engines, you obviously need to use SSR. Where you don't need
Uh,
to use SSR, I think in the majority of other cases. And I think SSR provides better user experience because your page is loaded faster. Customer can see everything in time in time your CSS is loaded, and you don't need to fight with page flickering. So if you are seeing about great experience, great user experience, you can use SSR as well.
okay, thank you so much. And we have one more question. Is it good for you like to join in our chat in our application, or we can just answer it here?
I think we can answer it here.
Okay, are the micro fronts able to communicate with each other, and how do you provide that feature?
Mhm. So, out of the box, we don't provide a way to communicate between fragments. But if you need it, sometimes you need, for example, sometimes one fragment can affect another one. I think on web we have lots of things to do it. In our case, we are using internal browser events to communicate between them. But I think it's up to users. So we don't limit how to use it. And each consumer can create the system on their side. How to make it public and available for all fragments, you need to use these shared fragments. So you can deliver this as a part of shared fragments, and this will guarantee that all fragments use similar API to communicate.
Okay, that's it from our side. Thank you so much, Artem, for joining us and uh, just sharing your knowledge. It was pretty pretty good. Wow. Thank you so much.